Good morning, everyone. Today is Wednesday, so today we will finish 6.2 and start 6.3. Today you have homework 11 about 6.1 and 6.2, and then the quiz 7 is due tonight. If you go to Blackboard and click our course, so quizzes. Quiz 7. You are able to see quiz 7. So it's not just 30 minutes time answering. You can see the quiz 7 now. You have a whole day to work on your quiz. Is that okay, everybody? So no 30 minutes limit. Okay, so just submit your quiz 7 before midnight. Okay. Hi everyone. I just remind you today you have homework 11 and quiz 7. And quiz 7 is available now, and they don't have 30 minutes limits. So you have a whole day to submit it. Just submit it before midnight. You're welcome. And this is our evaluation. Right now, our response rate is 44%. We need one student, then it can help us to reach 50%. Then everybody will get 0.1 extra credits. And you see my other classes, they will get at least 0.4% extra credits. So if you haven't filled out the survey, please help me to fill out the survey. Thank you. And your comments are so important to me, and I'm happy to be your instructor this semester. By the way, I have already posted the pictures. So, where are we? Okay, this is our picture. Okay, good. So today, let's continue on session 6.1 and 6.2. So, by the way, you can start working on the practice exams. And tomorrow I will be in my office quite a long time, like from 10 to 1:50, and then after 3:20 to 6, and then 6:30, I will go to the Andover Commons second floor size conference room. That is the final study table. Okay, everybody? So I hope all of you to come to the study table. You can work on your practice exam there. And then when you have questions, you can ask. Okay? And the final review session recording is already posted on the website. Okay? So try our best. And nobody wants to retake this class, right? So we only have a couple of days left. So let's try our best to get a good grade. All right. So, okay. So last time we talked about how to solve system of nonlinear equations. So linear equations means all the power of x and y are 1. Nonlinear, it means the power of x and y are not 1. Okay, so one of them is not 1. That's why here, the first equation, x squared plus y squared equals 100. If you can remember the equation of the circle. By the way, this is our course website. At the very bottom, you have all the useful formula sheet for exam 1, 2, 3. Do you still have those? Okay, so make sure you memorize those formulas. They're very important. Okay, and then equation of circle. So the equation of circle is x minus a squared plus y minus b squared equals r squared. This is equation of circle. That's why if you see both x and y, they're to the power 2, and then the coefficients are the same, okay? And you have a plus between them, then you kind of know this is a circle. And this is a circle with, you see, your radius is r, and you have r squared. So r squared is 100, then r is 10. Right, everybody? R is 10. So this is a circle centered at the origin with radius 10. Okay? And the second equation is a line, right? And we talked about how to draw a line. You can express it as a slope intercept form. And then you can plug the y-intercept, and then you pick your slope. It's rise over run to find the next point, and you draw it. Then from this picture, do you see we have two intersection points? Mm-hmm. So let's solve the system and see if we get those 2 points. Okay. So last time we talked about use substitution method. Look at those two equations. Usually one of them, you get the power of x or y is 1, and then you can solve for that variable. In this case, do you see the second equation, the x and y, the power is 1? Mm-hmm. And then we solve for one variable in terms of the other one. But compare the coefficients. Do you see the coefficient of x is 3, and the coefficient of y is -1? Mm-hmm. So the y is better to work with. So let's solve for y. By the way, there are so many different ways to solve system of equations. And you compare all of them, and you want to pick the easiest and fastest. Right, everybody? Imagine we can also solve for x in terms of y. But you will end up getting, okay, move the y to the other side and then divide it by 3. When you divide it by 3, you have fractions. Do you like to work with fractions? No, it's very easy to make mistakes, right? So that's why, okay, we solve for y in terms of x to avoid fractions. Okay, this is equation 1, equation 2. So from equation 2, we solve for y. Okay, solve for y. So 3x minus y equals to 10. We subtract 3x on both sides. Oh, sorry. Do you have the worksheets? Oh, okay. Yeah, you have the worksheet. Okay. All right. And then we get -y equals -3x plus 10. Right, everybody? What do we do next? Chad. Yes, divided by -1. Then what do we get? 3x plus or minus? Minus 10. Yes. Let's call this equation 3. Okay, so you pick one of the equation and solve for a variable. And then put this back to the other equation. So that's why we plug in equation 1. Okay, equation 1, x squared plus y squared. X squared, write it down, plus y squared. See? We place the y by 3x minus 10 squared equals 100. So we plug in the first equation, x squared plus y. Y is 3x minus 10 squared equals 100. The typical mistake is students forget about the parentheses. So don't forget the parentheses. Everybody say parentheses. Yes. Okay. So you see we get an equation with one variable. Then we can solve for x. Yes.
Can we do it a different way?
How?
By setting x squared plus y squared equals 100 to y, and then putting it in. So
what do you mean by setting this to y?
So you subtract the x over
here.
Yeah.
Subtract the x over.
So just get y by itself.
But the problem is the square.
Yeah.
When you take square roots, you get an equation with square roots. So you have x, y equals plus or minus square root. And when you plug in, you get 3x. plus or minus square root of 100 minus x squared equals 10. Do you want to solve for this or this? Yeah, that's why the substitution method, you always take the equation such that x and y have the power 1. Yeah, this is a really good question. And it explains why we don't take that one. Okay, everybody? Yeah, very, very good. Okay. So now this is a quadratic equation, right? So we expand it. Okay, how do we expand it? So what's the formula? A plus b squared is what? A squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. Is that okay, everybody? So common mistake is students forget about the 2ab. Everybody say 2ab. 2ab. Yes, don't forget that. All right. Now this is like the a. This is like the b. What is a squared? Quinton. What's 3x squared? 9x squared. So 9x squared minus 2a is 3x times b is 10 plus what is b squared, Diana? B squared. This is b. What's b squared? 10. 10 squared is 100. Okay. Right, everybody? And that equals 100. So far, so good, everybody? By the way, if you forgot about this formula, it's okay. You just do, 3x minus 10 times 3x minus 10, and you distribute this times this times that, this times that, this times that. Is that okay, everybody? All right. And, what is x squared plus 9x squared? 10x squared. And this is negative, bless you, 6x times 10, right? So 60x. Oh, do you see the 100? You can subtract 100 from both sides? Yes? So, okay, we can cancel that. We get 0. Okay, good. We have the right-hand side as 0. And we can factor the left-hand side. What is the common factor, Haley? Like what you want to take out of the yeah. 10x. 10x, very good. And then what's left? Yes, x minus 6. Is that okay, everybody? We get quadratic equation. So expand it, combine the like terms. Oh, we can factor it. If we cannot factor it, then use the quadratic formula. Hey, what is the quadratic formula? Everybody say minus b plus or minus square root of b squared minus 4ac over 2a. Okay, yeah, good. All right, now we set each factor equal to 0. Okay, so this x is 0, and this is x equals to s. Yes, x equals to 6. Okay, do you see we have 2 solutions? And last time when we talked about system of linear equations, the number of solutions, it can only be 1 or 0 or infinitely many, right? But here for nonlinear equations, you can have other possibilities. Okay. So in this picture, because it's a circle, we can have 2 intersection points. So this is the x, Then we plug in this equation to find the y. Okay, if x is 0, y is 3 times 0 minus 10. What's that? Negative 10. Okay, if x is 6, y is 3 times x is 6, minus 10. What's that? Peter. 3 times 6 minus 10? Yes, 8. Okay, so the solutions are the first point, x is 0, y is negative 10. The second solution, x is 6, y is 8. Are they the intersection points? See? 0, negative 10, and 6, 8. By the way, on the final exam, you will have a problem like this, but I will give you the picture. Okay, everybody? So you're going to use substitution method to solve the problem. All right? Okay, so any questions about this example? No? All good? Okay, now how about part example 8? Okay, so please try example 8. Everybody try example 8. Pick an equation and solve for one variable. Mm-hmm. And let's get the substitution. So you pick one of the equations and you solve for one of the variables. So you see the power of x is squared, the power of y is 1. So it's better to solve for 1 instead of x. Because if you solve for x, you will take square roots. We don't like square roots. Mm-hmm, on both sides. Mm-hmm. And then plug in the other equation. You see, it's 7y, just the y. So replace it. And the x squared is here. Yeah, that's right. You get the y, and then you plug in one of the bigger equation. Or x. Do you need subline as well? Because you need to oh, this is because there's no external force. So we can just isolate it. Yes, this problem is because the power of the two equation matches. But that method only works for this particular example. Right. Okay. You get this. So that's why you label them. One, equation two. And you're using equation two to get this, right? And so then you plug in equation one. So don't plug in equation two. If you plug in equation two, you just get 0 equal to 0. It does not tell you anything. You get this from equation two, right? So you plug this in equation one. No, keep the two. Yeah, 2 times parentheses. And then
Yeah, because you don't put it back. It's going to be 7 over 1 times. Yeah.
plus or minus. Because you have square, you take square root is plus or minus.
Yeah.
Yeah, that's why you use the 2 points. Good job. Yeah, combine the electrons, move the constant to the other side. Oh, okay. When you take square root, you get plus or minus. So yeah, continue. Yeah, this should be. Looks good. Continue. Yes, good. This should be. Yes, 6 over 7. Oh, and don't forget the right hand side equals to 26 in the equation. 2 times 5. Yeah. Square equals right hand side. Now you can combine the electrons. Yes. Oh, this is the answer. Yeah. Oh, when you take square root on both sides, you get plus or minus square root. Oh, yes. Right. So let's see. Okay, where are we? Okay, so let's check our answers together. Okay, so here you can pick one of the equations because both equations we have the power of the y is 1. So you can pick any of them to solve for y. So this solution, I pick equation 1 and I solve for y. So I move the 3x squared to the other side. We got 2y equals negative 3x squared plus 26. And then use the whole y, so divided by 2. We got y equals negative 3 half x squared plus 13. This is equation 3. Then, because I pick equation 1 and get this, Therefore, you substitute to the other equation. So substitute to equation 2. Therefore, 5x squared plus 7 times y. This is the y. Everybody say parentheses. Parentheses equals 3. Okay? And then we distribute 7 times 3 is 21. So negative 21 over 2x squared. Plus 7 times 13 is 91. So, and this is like negative 10.5. 5 minus 10.5 is negative 5.5. Right? Everybody? Mm-hmm. And then you want to solve for x. Because we only have x squared, we don't have an x term here. So you don't have to use quadratic formula. You can move the constant to the other side and you take square roots. But when you take square root, you get plus or minus. Okay, everybody? Because it's a quadratic equation. How many roots you should get for quadratic equation? Usually 2, right? Everybody? That's why plus or minus 4. And then you plug in your y, negative 3 half. Do you see square? So plus or minus 4 squared is 16. Yeah, for 16 and 2 cancel, you get 8. 3 times 8 is 24. Negative 24 plus 13 is negative 11. Therefore, we get 2 points for negative 11 by negative 4 and negative 11. So far, so good, everybody? Okay, actually, for this problem, you can also use elimination methods, right? Do you see the two equations, the x power match, the y power match? So we can also do elimination methods. So you can find the LCM of the 3 and 5, which is 15. Then you can eliminate the x, and you solve for y, and then you plug in one of the equations to find the x. Okay? But the elimination method only works if for both equations the x power and the y power matches. Okay? In general, like this problem, the power won't match. Okay, so that's why I teach you the substitution method, because it works more general. So far, so good, everybody? Yes.
Why'd you substitute for, like you solve for y? Why'd you use the top of, like the second equation on the first one and you use the top one on the second problem? Like on this one, you use you use 3x.
Oh, okay. That is because this one, the power of x and y, they're not 1. So we cannot pick that one because if you solve for x and y, it involves square roots. You don't like to see square roots. Okay, because when you plug into the other equation, do you want to solve this problem? No, it's hard. Okay, that's why before you start, you compare both equations. Which one has the power 1? Pick that. Okay, and then for this problem, do you see both equations has the power y to the 1? So either equation works. So you can do both of them. Now which one do you take? Because I see the coefficients of the first equation is easier. Like 3, 2 is easier than 5, 7. Do you agree? That's why I picked the first one. Then yeah, to work with. Because if you pick the second one, it also works. Okay, it also works. But you divide it by 7. So you might need your calculator to help you. Is that clear, everybody? There are so many different ways to solve system of equations. And you try to compare and find the fastest way. All right? So, and then here we have some exercise. For example, here, you compare them. Do you see the only term the power is 1 is this term? Mm-hmm. So you pick equation 1 and you solve for y. Yes, everybody? Then you plug in the second equation. Mm-hmm. Yes.
So the one on the exam is going to be the first one, whether it's 2 squares on top.
It would be non-linear, but you will see at least one equation, one of the power is 1. Right, it won't doesn't look like it, yeah. So the one on the practice exam. Oh, okay. Yeah, like that. So yeah, on the exam, I don't guarantee. So maybe you have x squared here, but you will see one of the equations, one of the variable, the power is 1. Then you can pick that one to solve for that verse. Yeah. Okay, good. All right, so this is 6.1 and 6.2. Okay, so all right, we finished that. Now let's do the last session. Okay. All right. Oh, by the way, for those of you coming late, right now our response rate is 44%, but we just need one more student. Oh, okay, sure.
Just do it.
Oh, okay. Everybody will get 0.1. So if we have 2 more students to fill it out, then everybody will get 0.2. Okay.
We don't have 18 students.
Unfortunately, we have, but it just stopped coming to class. Unfortunately.
What about drops?
We don't have drop students anymore.
Really?
Yeah.
Wow.
Yes. Okay. And remember you can have me check your notes. Okay, so today or tomorrow, come to my office, have me check your notes, and then you get 1% extra credits. Yeah, if you so please make sure you fill out all the examples. If you miss one example, you lose 1. But in class, if I put exercise, then you don't have to do that. It's just the one that we go over in class.
What if we
Huh?
She's gonna have a copy of her own.
Yeah, have your own.
Okay.
Yes. You're welcome. Okay, good. So, all right, 6.3. Oh, yeah. Could you help me to distribute it? Thank you. Yes, just 1 page. Okay, so in the exam, we will have this last problem. It's going to be 3 equations and 3 unknown. Yes. Sorry. So I just turn it off and then I stop talking. Yeah. Thank you for reminding me. Okay. Yes. Oh, thank you. All right, elementary rule operations. These operations do not change the solution of this linear system. So we can multiply one equation by non-zero constant. This is what we have been doing. I remember that in linear diagrams, we find the least common multiple, and then we multiply some numbers to get that coefficients. And then we can add or subtract those 2 equations. Okay, so multiply one equation by a non-zero constant. This won't change the answers, the solution to the system. And then, or we can interchange 2 equations. So we can interchange them and call this equation 2, this equation 1. This won't change the solution. Or we can add a constant multiple of one equation to another equation. This won't change the solution as well. Okay? And actually, this is elementary operations. It's closely related to something called matrix. Because we don't have enough time in our course, so we don't have time to talk about matrix. But for like higher math, you will hear something called linear algebra, and then you work with matrix. So they convert a linear system into a matrix vectors form, and then you do the algebra. Yes, a systematic way to solve the solution. Okay, so let's see, how do we solve this kind of problems? let's use elimination method. Okay? So use elimination method. You want to eliminate one variable and then eliminate the second variable and then so that you get one equation with one. So let's compare the coefficient of x. They are what? 1, 3, 2. The coefficient of y, 2, 8, 7. Coefficient of z, 1, 7, 8. Just by looking at the coefficients, which variable has the easiest coefficients? X. Do you agree, everybody? So we eliminate x. So compare the coefficients. Then we choose to eliminate x. Okay, what is the least common multiple of, what are the coefficients of x? This is 1, 3, 2. What's the least common multiple of 1, 3, 2? 6. Is that okay, everybody? Yes. So let's call this equation 1. This is equation 2. This is equation 3. Okay, everybody? And we want to match the 6. Okay, equation 1. What do we do with that? Times 6. So please write down the operation. So equation 1 times 6. So your notation, if you put a circle around a number, that means the equation. And you multiply by the number 6. Is that clear, everybody? Please write down your operation. Okay, equation 1 multiplied by 6. What do you get, Peter? Yes. We call this equation 4. And then equation 2, what do you want to multiply to get 6? Even. 2. And then when you multiply by 2, what do you get? Yes. And we call this equation 5. How about equation 3? What do we want to multiply? Cora? 3. And then what do you get? 69. Very good. Okay, everybody? Do you see we have 3 equations? Now, we take 2 of them to get rid of x. So let's take 4 and 5. Okay, questions. Do you want to use equation 4 minus equation 5 or equation 5 minus equation 4? 5 minus 4. Why? So we have positive coefficients. Is that okay, everybody? Colin, 5 minus 4, what do you get? So 6x minus 6x is 0. 60y minus 12y, 4y. And then 14z minus 6e, az, 40 minus 24, 16. Okay, everybody? Now, don't call it equation 7 yet. Do you see all the terms have a common factor 4? Yes, simple. Do you like to work with small numbers or big numbers? Small numbers. Do you agree, everybody? So, if we divide it by 4, what happened, Quinton? Yeah, very good. So we call this equation 7. Okay? So we take the pairs equation 4, equation 5 to get rid of x, and we get this. Now we take another 2 equations. So do you see 3 equations? We actually get 3 pairs. You can do 4, 5, and 5, 6, or 4, 6. Okay, so you take another pair. Diana, which pair do you pick? So we pick 4, 5. Okay, now we need another pair. It's either 4, 6 or 5, 6. Which one do you pick? 4, 6. Okay, so if we do 4, 6, we want to eliminate the x. Do you want to do equation 4 minus equation 6 or equation 6 minus equation 4? 6 minus 4. Then what do you get, Diana? 6x minus 6x? 6x minus...
Oh, no, I was on the...
Oh, yeah, on the y. Okay, yeah, 9y. 9y, and then how many z? 21z equals 45, right? Good. Okay, do you see all the terms have a common factor? What's that common factor? 3, yes. When we divide it by 3, what do you get? Check.
49. Because 21.
Oh, yeah, because of 21. It's, yeah. So check, when you divide by 3, what happened? Yeah, 15. Good. Do you see equation 7 and 8? We have 2 equations and 2 unknowns, right? So we have eliminated the x. Okay, now look at these 2 equations. Look at the coefficient of y, 1 and 3. Look at the coefficient of z, 2 and 7. Which word will you pick to eliminate? Y. Do you agree, everybody? 1, 3 is easier than 2, 7. Yes, everybody? Mm-hmm. So we compare, like, there are so many different ways. We pick the easiest way. So now we eliminate y. Least common multiple of 1, 3 is what? 3. Okay, so now we're using equation 7 times 3. What do we get? S's. So equation 7 times 3, you get what? 3 times y is 3y. 3 times 2z? 6z. 3 times 4? 12. Yes, very good. All right, everybody, what do we do next? Peter. Yes, which one's the which one? Which equation is the equation? We look at this too now. See, we're looking at equation 8 and 9. Yeah, so how do you, okay, we have these 2 equations, right? We want to match the coefficient of y that we can say. So we use equation 7 multiplied by 3 and we get this. Yeah, equation 9. And then you use equation 8 minus equation 9 or equation 9 minus equation 8. Wait, which one is bigger? Which one is bigger? Yeah, so we use equation 8 minus equation 9. You see, this problem is harder because it involves more variables. So that's why it's more important to write down what you are doing. Otherwise, it's very easy to get lost. Okay, how many z? 1 z, right? And what's on your right hand side? What's on your right hand side? Oh, sure. Okay, Ethan.
Z equals 3.
Yeah, z equals 3. Okay. Okay, yeah, because I. Sure. 3, and then you add those two equations. If you get positive 3, then you subtract those equations. It will work the same.
Oh, so you're doing this, yeah.
Yeah, I'm doing the negative and then you add. Because the problem is when you do multiply by negative 3, you never should change the sign of these. They both work. So that's why I said there's so many different ways to solve the system of equations. Just pick the way you think is easier for you. Okay, good. Z is 3. Now what do we do? Yeah, plug it in. See those two equations? Which one you choose to plug it in? 7. Right, everybody? 7. Why 7? Yeah, the y has easier coefficients. Good. So we plug in 7. Okay, 7 is here. So y plus 2 times z is 3 equals 4. Okay, Nikima. What is y? Do you divide or you subtract? What's 2 times 3? 6. Y plus 6 is 4. Then y is 4 minus 6. Okay? Yeah. Negative 2. This is addition, not multiplication. So we subtract, not divide. Right? So y is negative 2. Is that okay, everybody? Mm-hmm. Good. Now go back. Go back. We have z and we have y. Then we plug in one of the equations to find the x. Which equation do we pick? Yes, equation 1. Is that okay, everybody? We plug in equation 1. So equation 1 is here. X plus 2y. What is y? Negative 2 plus z. What's z? 3 equals 4. So 2 times negative 2 is negative 4 plus 3 equals 4. Negative 4 plus 3 is what? Negative 1. So what is x? 5. 5, yes. So the point is x is 5, y is negative 2, z is 3. Okay. So yeah, this is your last problem on the final exam is like that. Your system of 3 equations, 3 unknown. You compare the coefficients in neither one variable. So you have 2 equations, 2 unknowns, and then compare the coefficients in neither one more variable, and then you can find the. Oh, thank you. Yes, find the value and then plug it in to find the y, and then plug it in to find the x. Have a nice day.